Hello, welcome back to Learn Physics. In today's topic, we are going to discuss about the kinetic theory. So in last video, we finished the theory portion. That time itself I told you I will be doing some numericals relating to this chapter, isn't it? So we are starting with the numerical. Everything is your textbook questions only. So first one from page number 333. Okay, exercise first question. Estimate the fraction of molecular volume to the actual volume occupied by oxygen gas at STP. Take the diameter of oxygen molecule to be 3 angstrom. So we should find out the fraction of molecular volume to the actual volume. So our aim is to find out molecular volume divided by actual volume. Okay, this fraction only we should find out. Okay, gas at STP. At STP, actual volume will be, what will be the actual volume at STP? Actual volume is 22.4 liters. Isn't it? It is 22.4 liter. Okay, then take the diameter of an oxygen molecule to be 3 angstrom. Diameter of oxygen molecule is 3 angstrom. Okay, so what will be radius? 3 by 2 angstrom, that is 1.5 into 10 to the power minus 10 meter. So here we will consider it as in centimeter, means it will be this minus 8 centimeter. Now we are going to find out the molecular volume. Molecular volume, how we can find out? See, in last, while we are explaining the theory, the number of molecules per unit volume is given as small n. Isn't it? To find out the total number of molecules, what we did, the total volume, how we can find out? See, the volume of one molecule into Avogadro number of molecules will be giving, because at STP how many number of molecules are there? Avogadro number of molecules are there at STP. So for one molecule, what is the volume into Avogadro number will be giving you the total volume of the molecule, molecular volume of the molecule, of the oxygen molecule. So for one molecule, it will be volume of one molecule. How we can find out? Here and all we are considering it as a sphere. Okay, so it is 4 by 3 pi r cube. 4 by 3 into 3.14 into 1.5 into 10 to the power minus 8 the whole power 3. Okay, this is a volume of one molecule. Then volume of Avogadro number of molecules, how much it will be? 4 by 3 into 3.14 into 1.5 into 10 to the power minus 8 the whole cube into Avogadro number 6.023 into 10 to the power 23. This is called a, what is this? This is molecular volume. Molecular volume. So we got actual volume also and molecular volume also. But here we are getting it in centimeter cube. Okay, so we can convert this also in centimeter cube. So we will be getting it as 22400 into 1000 centimeter cube. So now you can take the fraction and divide these two and you will be getting the molecular volume. So this divided by this you should do. Okay, it's a calculation. That one you can do it. Understood now? Now the second one, molar volume is the volume occupied by 1 mole of any ideal gas at standard temperature and pressure. Show that it is 22.4 liters. So how we can show that it is molar volume is 22.4 liters? See, we know for an ideal gas PV equals RT. So from here, if we are finding out V at STP, we will get it as 22.4 liters. So how we can do R? What is the R value? 8.314 into temperature at STP is 273 Kelvin. pressure is 1 atmospheric pressure, that is 1.013 into 10 to the power 5. While you are doing this one, you will get the answer as 22.4 liters. Okay, that is 22.4 into 10 to the power 3 you will get. Okay, so this is how we will be finding out the answer for this one. The next one, figure shows plot of PV by T versus P for 1 into 10 to the power minus 3 kilogram of oxygen gas at two different temperatures. Okay, so the diagram is given here. What does the dotted plot signify? This is third question. Okay, so here it is given as x-axis and this is y-axis. This is PV by T joule per Kelvin and this is pressure. Here one dotted line is given and here T1, it is given as T1 and another gas is given like this is T2. Okay, down one is T2 and this one is T1, like that it is given. Okay, so here I'll give this over here. Okay, what does the dotted plot signify? Dotted plot is, it is parallel to PV by T is a constant. At different temperature, PV by T is a constant. PV by T equals, by ideal gas equation we know PV equals RT. So PV by T will be equal to R. That is a constant. So this line will be signifying which one? Yes, it will be signifying an ideal gas. Okay, clear? So the next one is, which is true? T1 greater than T2 or T1 less than T2? So T1 is T2. See, T1 in this equation, whether T1 greater than T2 or T2 greater than T1. Okay, so which one will be first touching this ideal gas equation? That is, ideal gas condition is PV by T is a constant. This is ideal gas equation. T1 reaching first, then only T2 is coming, isn't it? For smaller pressure. So when the temperature, when the condition will be reaching the ideal gas equation fast, as temperature increases, it will try to attain the ideal gas equation fast. Okay, so which one will be? T1 will be greater than T2. As temperature increases, the gas will be approaching the ideal gas fast, equation fast. Okay, so T1 greater than T2. Then next one, what is the value of PV by 2 where the curves meet on the PV by T where the curves meet on y-axis? See, PV by T, see, they are meeting at this point, isn't it? So at that point they are getting the same value. That will be the point of R, isn't it? Since R is a constant, isn't it? Universal gas constant. So at the point R, it will be meeting each other. If we obtained a similar plots for 1.00 into 10 to the power minus 3 kilogram, that is, we can substitute the values and find out. That is not required. So the next question is, next one. An oxygen cylinder of volume 30 liter has an initial gauge pressure of 15 atmosphere and a temperature of 27 degrees Celsius. After some oxygen is withdrawn from the cylinder, the gauge pressure drops to 11 atmosphere and its temperature drops to 17 degrees Celsius. Estimate the mass of oxygen taken out of the cylinder. Okay, so here it is, initially oxygen cylinder has 30 liters of oxygen. Okay, and its pressure was, so initially, so this is fourth one, initial case. Okay, it has a volume of, initially I am taking it as 30 liters and it has a gauge pressure of 15 atmosphere and temperature of 27 degrees Celsius. After some oxygen is withdrawn from the cylinder, gauge pressure drops to, so final. Okay, gauge pressure drops to 11 atmosphere and its temperature drops to 17 degrees Celsius. Estimate the mass of the oxygen cylinder. Mass we should find out. Given that R is equal to 8.31 joule per mole per Kelvin and oxygen has molecular weight as 32 atomic mass unit. It's given like that. So how we can find out how many number of molecules are there here, how many number of mole of oxygen is there in the 30 liter, that one we should find out. Okay, how we can find out? See, PV equals nRT. This equation we know. P1 V1 equals N1 R1 T1. So what is N1 here? P1 B1 divided by R T1. R is a constant. No need to put 1 and all. So here first everything we should convert it into SI system. That is at atm to Pascal, 15 into 1.01 into 10 to the power 5 Pascal, that is equal to 30 into 10 to the power minus 3 meter cube, and here 27 plus 273. Okay, substituting all these things, that is 15 into 1.01 into 10 to the power 5 into 30 into 10 to the power minus 3 divided by 8.31 into 10 to the 27, that is this one you will get it as 300. So 300. You can find out N1 value, and then here in the same way here also after leaving this, what will be the N2 value, that is N2 equals P2 V2 divided by RT2 you should find out. Okay, N2 we don't know. See, what will be this, how many number of molecules are there? Depending on one molecular weight is 32. So 32 into this many number you can find out. Now this N2, what is V2 here? The volume, cylinder volume is not changing, right? So N2 equals P2 V. Here also we can take it V1 V only, because here the same cylinder we are using, so we can use like that. So 11 into 1.013 into 10 to the power 5 into 30 into 10 to the power minus 3 divided by 8.31 into 17 plus 273. Okay, so you will get it as 290, that one you can find out. So here you are getting N1 and here you are getting N2 also. So here total mass how you can find out? N1 into 32 you should do. Okay, here M2 mass will be equal to final stage what will be the N2 into 32. Okay, here you are getting mass of N1 and particle, and here you are getting the mass of N2 particles. Okay, so while you are subtracting M1 and M2 you will get the final answer. So understood how we are finding out this one? All these are the non-formulas only, just application you should understand, that's all. Okay. Next is an air bubble of volume 1 centimeter cube rises from the bottom of a lake 40 meter deep at a temperature of 12 degrees Celsius. To what volume does it grow when it reaches the surface, which is at temperature of 35 degrees Celsius? Okay, an air bubble of volume 1 centimeter cube. So volume is given as, what is that? 1 centimeter cube. So 1 into 10 to the power minus 6 meter cube. Okay, and rises from the bottom of a lake 40 meter deep at a temperature of 12 degrees Celsius. So initially it is at the volume of an air bubble 1 centimeter cube. So initially V1 like this, and it's rises from the bottom of a lake 14 meter deep at a temperature of 12 degrees Celsius. Okay, so T1 is 12 degrees Celsius plus 273. So you will get it as 285 Kelvin. Okay, and to what volume does it grow when it reaches the surface, then which is at a temperature of 35 degrees Celsius. So V2 you should find out. T2 is given as 35 plus 273. So 308 Kelvin. Okay, so how we can find out this one? So we know that PV equals nRT. Okay, so oxygen molecule, one bubble only, we have an air bubble of gas, that only we are considering, right? So here how we can find? So PV equals RT, then here volume we should find out. So we know that PV by T is R, that is a constant. Isn't it? PV by T, that is a constant. So here we can write it as P1 V1 divided by T1 will be equal to P2 V2 divided by T2. We don't have P1 and P2, but V1 T1 and V2 we should find out. T2 we need to find out. T2 we have. Okay, so P1 and P2 how we will find out? It is at a depth of, the depth is given as how much? 40 meter deep. So how we can find out the pressure? Atmospheric pressure plus how much? Rho GH. You can find out this. Okay, when it is reaching to the top, what will be the pressure? It is 1 atmospheric pressure. Okay, 1 atmospheric pressure means you should consider it as 1 into 10 to the power 5 plus rho GH. Here also 1 into 10, 1.01 into 10 to the power 5 Pascal you can find out. So now you have P1, V1, T1, P2, T2. You can find out V2. Okay, clear? So this is how. So I am just telling you how to do, and the rest of the calculation you should do. Okay. So next one, estimate the total number of air molecules inclusive of oxygen, nitrogen, water vapor and other constituents in a room capacity of 25 meter cube at a temperature of 27 degrees Celsius and 1 atmospheric pressure. See, we should find out the total number of molecules, not per unit volume and all. Okay, so we should find out the total number of molecules, means N we should find out. Okay, then it is given as in a room capacity of 25 centimeter cube. So 25 meter cube. So it is no need to convert, and then at a temperature of 27 degrees Celsius. So 27 plus 2, 73, 300 Kelvin. Okay, and pressure is given as 1 atmospheric pressure, 1.01 into 10 to the power 5 Pascal. So how we can find out this capital N? See, PV equals nRT. Okay, N is the number of moles. Okay, so here N into R we can write it as Na into Kb. That one you know, isn't it? See, this is number of moles and Na is the number of molecules per unit at STP, isn't it? In 22.4 liters, this many number. So total number of molecules if they are asking, you should find out N into Na. So how you can find out N into Na? N into Na equals PV divided by KBT. Okay, all these values you know, right? So from that you can find out the value of N into Na. Okay, clear? So next one is estimate the average thermal energy of helium at room temperature, that is 27 degrees Celsius. The room temperature on the surface of the sun, that is 6000 Kelvin. The temperature of 10 million Kelvin, that is a different temperature. You should find out the thermal energy. Thermal energy means it's due to temperature. Average kinetic energy. What will be average kinetic energy? 3 by 2 kBT. So 3 by 2 Kb is the Boltzmann constant, it is constant, and temperature value you should substitute. The respective temperature values you should substitute, and while substituting, convert everything into Kelvin. Okay, that one don't forget. So 7th one, the 3 by 2 kBT, that is the formula. Okay, temperature convert in Kelvin. Okay. So these are some of the questions which I did till 7th question. The rest of the questions I think you can do it. It is easy, only the same way. Whichever formulas, only 3-4 formulas we learned in this chapter, right? So all these formulas, using that formula only you can find out, understand the concept. That is the main thing. Okay. So I think it is clear for you. And if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.